The next topic is the earthquake time history record. A time history record is fundamental to a QUAKE-W analysis. We cannot do a QUAKE-W analysis without specifying an earthquake record. The earthquake record is a trace of acceleration versus time, and often the acceleration is expressed in terms of the gravitational constant g. So when we say 0.2 g, it's 0.2 of the gravitational constant. So here is a typical earthquake record where we have time and we have acceleration in terms of g. QUAKE-W always uses the input in terms of g. It's a percentage of the gravitational constant, or a ratio of the gravitational constant. So we need to import a record into Quake, and we can import the data from a text file, and there are several text formats that Quake will accommodate. Alternatively, if the record is in Excel, you have acceleration versus time, or time versus acceleration. In Excel, we can paste the data from Excel into the Quake edit boxes. We can modify the peak acceleration or scale the acceleration record. Here's a scaling value. And we can also make a baseline correction, which we will demonstrate here in just a few seconds. But the baseline correction simply attempts to make the area above and below the curve equal. So if we have an earthquake record, the baseline correction is simply a linear regression analysis, and the attempt is to make this area here above the curve equal to the area under the curve. There is nothing particularly sophisticated about this baseline correction. I recognize that there are many other procedures for doing that, but in QUAKE-W we have implemented this simple method of a linear regression analysis, trying to shift the data points up and down so that the area above the zero line is the same as the area below the zero line. For an equivalent linear type of analysis, it's important to do some preconditioning on the shaking record. For a quake analysis, particularly the equivalent linear type of analysis, we should only use the strong motion portion of the time history record. Recall that we are only looking for peak values, and once we have established the peak values, then any analysis thereafter to the end of the record is really not necessary. And so we can make the analysis manageable by deleting unnecessary data from the earthquake record. We can delete the data directly in the QUAKE-W dialog box, or alternatively, we can take all of the data, copy it to the clipboard, take it into Excel for modification. I have here an earthquake record of the Northridge earthquake, and I demonstrate what I mean by getting rid of unnecessary data. So here is a typical earthquake record, the way you may find it. And my point here is that we could eliminate all of this data. There's 30 seconds of shaking here, which will not alter the equivalent linear type of analysis. By this time, the peaks have been determined, so this is unnecessary here. We don't need to do this part. I would also suggest that there is a good portion up front here that also does not contribute, and we can get rid of all of this data. And when we do that, then we might land up with an earthquake record that looks like this. We have 30 seconds. Once again, we might even further modify this by removing this part here. If we don't do that, then we get far too many analyses and it takes too long. While computers today are fast, they still have a limit as to the number of analyses that can be done in a reasonable amount of time. So, recall once again, sorry to repeat it, but we are looking for peak values. And the peak values, they occur in the strong motion portion of the record. And so it is really the strong motion portion that we are interested in for an equivalent linear type of an analysis. The earthquake record is also related to the size of our time stepping, and we can make the delta t, the time stepping sequence, equal to the delta t between the data points in the earthquake record. Generally, this is a good default way of doing it. Our delta t can be larger than the delta t between the data points, but there is not then we would miss some information. We could make delta t smaller than the delta t between data points, but this gets to be too much in the analysis and unnecessary. So generally, we make our delta t time stepping equal to the delta t between data points in the record. Now, sometimes in modern earthquake records, the delta t, or the earthquake motion, has been recorded at very small time steps, and so sometimes it is necessary to remove the odd data point from the record, or even every second data point, such that we get in a meaningful number of data points for a QUAKE-W analysis. So often records have data at every 100th of a second, and some records even have every 5,000ths of a second. This means that we get 100 to 200 data points per second, and if we have 10, 15, 20 seconds of shaking, it is an awful lot of data points. Generally, as a very broad rule, 50 points per second, or about a delta t of 2/100th of a second, is generally adequate for a QUAKE type of analysis, particularly for equivalent linear type of analysis. So while it is probably somewhat cumbersome to take a record and remove the odd point or every other point, it is nonetheless a worthwhile effort to spend some time on preconditioning the record, because otherwise the QUAKE-W analyses become too cumbersome and too tedious. So as I've already noticed and noted here in this slide, sometimes a good idea to remove every second or fourth data point from the earthquake record. Generally, this is best done in Excel. So let us now go to GeoStudio and import a earthquake record that we have supplied for this illustrative example. And we will modify the record and set the peak ground acceleration to 0.2 g, and then we will set up our time stepping sequence. So going then to GeoStudio, so as I've already said, sometimes it's a good idea to remove every second or fourth data point, for example, from the earthquake record, and generally this is best done in Excel. So let us now go to GeoStudio and import an earthquake record that we have provided. It's an example record that we ship with the software. We will modify the record and set the peak ground acceleration to 0.2 g, and then at the same time we will set up our time stepping sequence for integration through the earthquake record. So we go key in horizontal earthquake records, and we get this dialog box, and we are going to import a record. Clicking on import, we want to import example.acc. We have an extension on the text file for the earthquake records of .acc, and then we say open, and we now have imported an earthquake record. Usually the first thing to do is to click on View and take a look at the record as to what we have imported. And we see that the peak ground acceleration from this record is over 0.3, and we have a duration of shaking of 10 seconds. So there's not a lot of preconditioning that is required, because we've already done that in the past for shipping this example case. So the first thing we want to do is we want to set the peak ground acceleration to 0.2. So we type in here 0.2, and then we click on Apply. And now when we look at View, we see that our peak ground acceleration is 0.2. So the entire record has been scaled up and down so that the peak is 0.2 instead of the default value in the record. Now it doesn't make a lot of difference in this case, but we can click on Baseline Correction and we can click on Apply, but this record has been worked with so much that the baseline correction doesn't make much change. But one last time, looking at our record, we can see all the variation and acceleration with time. And so this is the 10-second shaking record that we're going to use in our illustrative example case. Now once again, we could highlight various data points and click on Delete. We can say click on Select All, but the most important part is that when you right mouse click in this dialog box, you can copy all the data. You can select all the data first and then copy the data and paste it into Excel for further modifications if you wish. Sorry, going back to that same dialog box, we can also, as I already noted, either delete individual points or groups of points. It comes down to a matter of personal preference as to where you wish to spend your time to precondition the earthquake record. Now that we have imported a record in our dynamic analysis, we go back to Key In Analyses, and under our dynamic QUAKE analysis, and now we need to define the time stepping sequence. And you notice here that we have a checkbox that says get the time steps from the horizontal earthquake record. And by checking this box, it looks at the earthquake data and it says, oh, the record has a data point every 2/100th of a second. And as a result, we have our time stepping sequence here. And we have all of the data points at a delta t of 2/100th of a second. And as a consequence, we have 500 steps to analyze for a total duration of 10 seconds. Now, usually we do not save all the data for every time step. It simply gets to be too much data. So in this case, we are only saving the data every 10th step. But you're familiar with this from SEEP and Sigma in earlier studies of the GeoStudio products. So, in summary, we import an earthquake record. We have to precondition the record, and then we can use the record to create a time-stepping sequence for the temporal integration through the earthquake record and the dynamic shaking analysis. Many users, when they first encounter QUAKE-W, rather despair at the fact that they need to determine and acquire an earthquake record. But as I've noted previously several times, a record is necessary for a QUAKE-W analysis, and fortunately there are many sources of these types of records, and many of the historic records are available from public government agencies. Government agencies in almost every country maintain some seismic recording stations, and contacting these government agencies you can get typical earthquake records for a particular site. There are also many local university geological and geophysical departments that record seismic activity, and so often you might want to contact your local universities to see if they have any records of earthquakes. Also, generally, records that can be scaled to site-specific peak accelerations, and this is more than adequate in many cases. It does not need to be a record exactly for that particular site, and this is more than adequate for particularly for preliminary sensitivity studies. The seismic record should come from an area of the country where your project is located, because there are differences in frequency content depending on the part of the world and the part of the country as to where the seismic activity is taking place. But in the end, if it becomes critical to your project that you have a well-defined earthquake record, I would highly urge you to work with a professional seismologist and have so that you can get an appropriate record and get confidence in the record for your particular high-profile project. Working with a professional seismologist may be well worth the time and effort for you in some cases. So one last point about the shaking analysis is that we have what we call history points. As I noted a little bit earlier, we don't save the data at every delta t during the time integration through the earthquake record. It simply produces too much data. And yet we want to look at the complete record at certain points during the analysis, and so we have in QUAKE-W what we call history points. And it allows you to flag certain points where data is saved at all the time steps. If we save them in the regular way for all time steps, the files just simply get too big, and it becomes too slow to filter the data in the results view afterwards. So the history points are primarily intended for looking at the response of the earth structure to shaking. And so in our illustrative example, let's proceed and set up two history points. Let's put one history point on the crest and one at the base of the analysis. Going then to GeoStudio, we have imported our earthquake record, and we will define two history points. So we can say draw history points. We'll click on our mesh for the time being, and so we will have a history point on the crest. A history point has to be drawn on a geometric point, and so we can say draw a history point. We have a geometric point here at the crest. We can put one history point there, but we need a geometric point at the base of the analysis. So first of all, say draw points, and we will put a point here at the base of the problem. Once we have a geometric point at that location, we can draw a history point at the same location. We notice now that we have two history points. We'll turn off our boundary conditions and our mesh here for the time being, so we have a history point. We have a history point here at the crest, and we have another history point here at the base of the problem. So once again, history points are for flagging certain points at which we want detailed information.